Hi everyone, welcome back to Brain Lab Techies, and this is a day 3 of our playlist Complete Statistics for Data Science. And hi, I am Suchana. But before starting the video, I would like to thank you all of you for being the part of our Brain Lab Techies family. Let's grow together, and thank you so much for your engagement, means your likes, your comments, your subscribes. Each and everything motivates us a lot to make the videos, and your feedback really help us a lot. So do give the feedback in the comment section. We really want to hear from you, and if you feel anything we could improve from our end, will definitely try to improve. Okay, so just write your feedback in your comment. Okay, so let's start the video. So in the day 2 we already have discussed that how this descriptive statistics is coming in data science, and what is that descriptive statistics means. A branch of statistics that helping us in the data science to summarize, to organize, to visualize the data. And in like account of that, we already have seen and implementation in Colab file. You already have seen this is the Titanic dataset we already have imported. Now we are reconnecting this Colab environment. Now if you can see here, this df we already have imported, and this is the file. Now if I want to execute our file, so what you have to do here, as you can see in the files, the existing tested, our data set name was tested.csv, that is not present inside this files option. So what you have to do, from the local system you just have to find that csv file, and you have to drop it again, so that it will re-execute. Otherwise you may face error. Not you may, you definitely face error. So first of all you have to upload this again, then you can go for run all option, and see now it's running perfectly without the csv file. If you're going to run all this thing, then you will definitely find error. So this is the first step you have to do. So we'll work on the same thing. This is the data set, and already I have told you in the beginning of our playlist that we will be going through technical way, not only theoretical. So with this data set we will be learning all the concepts of data science. Now what we have discussed in the last video, that is, we were taking the help of Panda as a library, and with the help of Panda we are reading the csv file, which is consist of some columns. Now how many columns present? So df.shape we already have used, where it is showing 418 comma 12. So 418 basically your rows, means the number of records. 418 records are there, and 12 is the number of features you have. So basically features, what is the features? I already have mentioned that the number of columns, this passenger id, survive, p class, name, sex, age, these are all the columns, and these columns all total we have 12 columns, and these are actually considered as features, and which is very important because in data analysis this features is the main thing that you will be doing the analysis on. Okay, and df.info, this is also important. Already we have talked about that, how much my data is clean or not. This is the thing, null count it is giving. Now the main thing is this df.describe. Now this is the thing, df.describe. Now if you run again, I am running this df.describe, what it is doing actually. So just observe one thing in the df.info. As you can see here, there are some different data is there. Now this data, some of the data type, if you see this d type, some of the data d type is showing int 64, and some of this object. Okay, what is this actually? If you like closely looking to it, this passenger id is giving some number values. Okay, survived is giving some records in numbers, p class also the same, name in the letter format, like in string format, sex also in the string format. Now on the same way some numbers also present, and here in cabin and the embarked, there are also some um, letters or the string format data present. Now here, as you can see in the info portion, passenger id, this is int. So this is where number present, that number d type is showing as int 64, and where there is string data type present, there it is showing object. Now in data analysis, or you can say in statistics, like more specifically in statistics, whenever you are going for this descriptive statistics, first thing, you need to know about the type of data. Already you know type of data we have the depending on the collection, primary data and secondary data we already know. Now if you go for any data analysis and you are looking, you are like handling a table, and that time this data can be two type, the entries. We are talking about the entries. Now some of the entries you will be getting in numeric format. Now numeric format, and some of them in string format. Now this numeric format data where number present or the decimal values or float present, those type of data we will be calling as quantitative data. Quantitative data or numeric data simply. Now the data which are not in numbers, not in numbers format, that data you can say that categorical data. Categorical data. Now based on these two types of quantitative data and categorical data. Now quantitative data here, as you can see, this passenger id, the d type is what, int 64. Now this is what, this is a quantitative data. Okay, and survived, quantitative data. On the same way, this name is a object. Now this object type data means what, means a categorical data, or other way you can say also qualitative data. Qualitative data means which is giving or showing you some quality. Qualitative data. So this quantitative data example, then any numeric data means number of students, number of students, heights, weights. So these are all numeric data, and the d type it will be showing in our technical format. It's in 64 like this. Okay, and if I go back to categorical data, now categorical data means anything which is in the string, like any name or anything like the status or any color, any location or the address. Now these are all the type of data which are in string format or in the alphabets, which is not a number. So those are also data. Now if you're going to handle this type of data, let me tell you, like in the numeric data also there are two classification. If you closely observe here, number of students is a type of data which cannot be mm, getting, we can't get as a fraction value. It should be always a number, a whole number, always it is, like starting from your zero to any value, but it should not, like it cannot be a fraction, right? So based on that, you can classify this quantitative data into two ways. First way is if it is a proper a whole number, if it is an integer, most specifically if it is an integer, then you can say this is discrete data, there is no continuation. This is what called discrete data in descriptive statistics, means there is no continuation, like number of students, any number of thing, like this number of students or number of commodities or any number which is countable, that thing you can't make it a fraction. Now what you can make, you can get as a fraction value, that is actually considered as your continuous data. Now this continuous data means you can take an example, that weight. If you're going to take your weight, it is not in proper whole number format, Like after this, suppose you have the weight of 65 kg. Now it's not properly 65, it should be like 65.753229, like this, and it's in continuous format. And every time, like you are always, whenever you are measuring your weights, it's actually going up and down. It's not a fixed value, because every time if you are alive means your weights are also fluctuating every time, so it's a continuous value rather than a complete number. So that's why it's considered as as a continuous data. Now even your age is also interesting continuous number. Why? Because every time you are telling your age, it's not a fixed value. Whenever you are telling some age, like whenever your age you are telling, that time some minutes, some seconds is also going on, right? So it's a continuous thing. Like if I ask you the exact age, you can't say. Like if you are saying, suppose your age is 23, now 23 years old. Now how many months? Let's suppose it is like, if your age is 23 plus, so 23 years, now 7 months, you are telling 7 months. Now in days also you can say like 11 days. Now 11 days, then after days what you can say, how much hour? So you can say 6 hour, and then 7 minutes, and then 5 second. Now whenever you are telling means some seconds also going on, right? So that's why you can't also properly telling your actual or the exact age. It is always in a continuous manner. Now this type of data is also called contiguous data or continuous data. Okay. And the qualitative data, now talking about the qualitative data, that thing you are getting as object format. Now this object format data means the categorical data. Now this is also important because we have to handle this type of categorical data as well. So categorical data can be classified into two ways. One is, if you say this number, okay, so number, num sorry, name. So if we talk about the name, so this name is actually the nominal data. Like we can classify this categorical data in two ways, nominal and the ordinal. This two way, nominal and ordinal. Now what is nominal? Nominal means any name. That thing you can't make it in a order. Okay, so any name, any location, these are all example of categorical data. Name or location, you can't really sort them in a proper way. Those type of data, those type of categorical data is considered as nominal data. Now ordinal data means those data which you can classify them, or you can make them in proper order manner. Means, let's suppose I'm taking status. Now status means it can be like high, medium, or low, medium. Now if I say, can you or make it in order? Yes, we can, right? So low, after then mid, then high. So you can make it in order, right? Now if I talk about the color of eyeballs, if I ask you the color of eyeballs, then which type of categorical data it is? It's a color. Now can you order, make it in order? Obviously, no. So, if it is eyeball color or hair color, so that will be a nominal data. Hair color, it will be a nominal data. Whereas ordinal data means any status or um, any value that you can make it in order. Now, these things also we will be learning how to handle this type of nominal or ordinal data. Next, let's go to the next part. This df.info. Now here you have already understood why it is int64 and why it is object. Now here also, as you can see, this age. Let's go back to age. Now age is like in floating points. Floats are there, so that's why float 64 it is showing. Okay, as because this is continuous data. Now, after this, we have one more execution of this line, df.describe. Now, what is that? df.describe, if you see some measurements, some values it is showing for passenger ID, survived, P class, age, C base B, purge, fair. For this, only this, like only this 7 columns, it is showing like this. Why these 7 columns? Now, if you can see here, only this 7 columns out of 12 column, we have 7 columns in integer format, and like in numeric format we have 7 columns we have in numeric format. Two of them are float, as you can see here, two of them are float and five of them are integer. Now for them only it is showing some describe method is showing some values. Now what are the information it is showing? Count, mean, STD means standard deviation, MIN means minimum value, 25%. You will be learning this is called quartile 1, 50% this is quartile 2 or your median, 75% means your quartile 3, and the maximum value. Now these are all 8, 1, 2, 3, 4, 5, 6, 7, 8. So 8 measurements of descriptive statistics it is showing. So what descriptive statistics is? It is for describing some value about what? About the features. As you can see here, passenger ID. So from these values, what you are getting? You are getting some knowledge about passenger IDs. You are getting some knowledge about survived. You are getting some knowledge about age, P class, like that. This. So it is showing some measurements of descriptive statistics by which you can get the knowledge from any particular column, or better to say features. So what is a feature then? So whenever we are doing data analysis, we are dealing with what? We are dealing with the tables. So I'm just drawing a table. Better to paste the table. So this is our table, and here as you can see, we have this 12 columns. Now these columns we will be talking. These columns, this passenger ID, survived, P class, name, sex, age. These are all the columns. We have ticket, rare, cabin, embarked. So these are all what? These are all called features. Now features means what? Feature means all the columns. Now if I do data analysis, what data analysis is? Data analysis means analyzing the features. So what we are doing? We are analyzing features. Features means what? The columns. Why we are bothering about columns? Because this columns is giving us the knowledge about the entire data. Now we have some records here, by which, like why this records present? What is this records? The number of rows. This number of rows are basically, these rows are actually considered as records. Now why this records present? Why we need records? As because we are, like we are dealing with columns, so if only those column present, then why we need rows for that? Because to understand each and every column we need the rows, because each and every columns is having this number of records, and based on that we are getting some value of the measurements of the individual column. Okay, so to analyze the features, to analyze the features we need rows. Means if I breaking down in the entire thing, we are analyzing first, we are analyzing data. Now analyzing data means we are analyzing what? We are analyzing the individual, each and individual columns, or these columns, better to say features. We are analyzing features. Now we are analyzing features based on what? Based on, we are analyzing features based on the rows. So that's why rows and columns both are important. Now whenever we are analyzing these columns, how to analyze this column? Means what are the approaches we have to analyze the columns? Now let's talk about analyzing feature. The techniques to analyze or analyzing the features. Now analyzing features means, if I going to analyze with only one feature, means one by one. Let's suppose we are analyzing one feature every time. Then that technique we will be calling as univariate analysis. So in data analysis, this is a first approach when we will be dealing with only one feature. We will be understanding each and every feature individually. That's what we will be calling univariate analysis. Now the next thing, if I take two columns every time and we are going to get the relationship between two features. So that time, if I take with two features, that time it will be considered as bivariate analysis. And then you will be asking that what about multiple features? Can't we take multiple features? Yes, we can. So whenever we are going to deal with more than two features, or let's suppose we are going to get the understanding about multiple features or factors impact on a single data, on a single feature, that time multiple features, if I going to analyze, that time it will be considered as, that approach is called multivariate analysis. Multivariate analysis. Now each and every technique is important. For each and every analysis we have different visualization also. So obviously when we will be technically doing those things, like technically when we will be going for visualization thing, for visualization we will be taking some help of Python libraries. Obviously that time we'll learn about Matplotlib, Matplotlib and Seaborn. Now this goes for your visualization purpose. This two library we will be using. And for measurements, if I go for descriptive statistics measurement, so that time will take help of, already we used Panda, so we'll use Panda. And for, like, whenever we need, after beyond Panda, we may sometimes we need NumPy as well. So for the measurement purpose we will be using these libraries, NumPy and Panda. Now, what are the topics we will be learning in this univariate analysis or bivariate analysis and multivariate analysis? So, for descriptive statistics, we will be starting with central tendency in human univariate data, central tendency. Now, after central tendency, we will be learning quartile. After finishing quartile, we will be learning dispersion, the measures of dispersion. Now, after dispersion, we will be learning skewness and kurtosis to understand the scatterness of the data. Skewness and kurtosis. Now, for bivariate analysis, we will be going with correlation. Now, in correlation also, we will be doing one thing, covariance. And after correlation, we will be learning regression. For bivariate data. For multivariate data, multiple regression it is there. Multiple correlation and multiple regression. Multiple regression. Now these are all our descriptive statistics plan for the next videos. So we will be in the next video, we will be starting with central tendency, where we will be learning mean, median, mode, and quartile. There will be a separate video. Dispersion, there we will be learning range, um, mean deviation, standard deviation, variance, and then skewness and kurtosis. There will be another video. So stay tuned. That's all for today, guys. I hope you understand, and still if you have any doubt, simply you can do comment and we'll get back to you soon. So see you in the next video. Thank you all. Bye bye. Thanks for watching.